Hello everyone, welcome to Meetup 26 by Kaggle Days Meetup Delhi NCR. I hope everyone is fine. I am Aman, your host for today's meetup, and in today's meetup we will be discussing about best practices and memory efficient coding in Pytorch. And for today's meetup, we have invited Tanay Mehta, who is in computer science undergraduate and Kaggle Days Notebooks master. And apart from that, Tanay is working as an applied research intern at NVIDIA. So, Tanay will be guiding us throughout the session discussing about PyTorch. And thanks, Tanay, for joining us today.
Yeah, thank you guys for having me. Super excited to be a part of this.
So guys, without wasting any more time, let's quickly jump to the agenda. For the first 45 minutes, we will be discussing about, and Tane will be giving his presentation on this topic. And in the last 15 minutes of this meetup, we will be having some short questions, and we will have a short Q&A session with Tane. So let's start this particular session. So Tane, up to you.
Yeah, so I hope you guys can see my screen. So first of all, hey guys, I'm Tanay and Tanay Mehta. I'm a final year computer science undergraduate. I'm currently pursuing computer science and engineering degree. I work as an applied research intern at NVIDIA, and I am a Kaggle notebooks master and competitions expert. Also, along with that, I'm a dev expert at weights and biases. So I started using Kaggle, and my Kaggle journey really started last year when I started taking data science and competitive data science more seriously. So yeah, that's it. Let's just quickly jump to the work. So this talk is about best practices and memory efficient coding in PyTorch, and I know a lot of frameworks are available out there for machine learning and data science, but I really like PyTorch more, and it's not really about a bias. It's just a personal preference. So I thought maybe it's a good idea to give some best practices in memory efficient coding that you can do in PyTorch. Yeah, so so a quick introduction to PyTorch for those who don't really know about the framework. So PyTorch is an open source machine learning framework. It's built on top of the Torch library that was initially released for Lua programming language, and it's created by Facebook's AI research lab. And the reason why I chose PyTorch for this one is because I've seen this personally, that it's used a lot in Kaggle competitions, and I realized this later on at some point, that it's really used for its flexibility. So that's one of the main reasons why I learned it, and why this all is being organized. So yeah, so to give a quick introduction on PyTorch and to make sure that we all are on the same page, I'm going to uh, start with a simple image classification example. So if you have some basic knowledge of deep learning, it should be fairly easy for you to catch up. So yeah, so I'm going to go over through some image classification example code, and I will explain what each and every line of the code does, so you know more or less what the PyTorch version of a basic image classification example is. So the code snippets that I'm going to be using in the following slides is from my training notebook in a past competition called Cassava leaf disease classification competition that was hosted on Kaggle a few months ago. So after this event, you can just go to the slides and click on the link to 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 view the actual notebook, so you can see it for yourselves and catch the samples up. So one thing to keep in mind especially is that the the code samples that I'm going to show you, and the style of coding is not really a state of the art, or the best practices. It's just the sort of coding that I do myself, and that I have evolved over the past few months and years. So yeah, so it's great to keep that in mind. Right, so this is the model class. So let's just quickly get started. So in PyTorch, you can actually you can do this all thing in one line of code too. It's not really that hard, but I like to make it more customized, so you can actually do it in a more custom way. So I'm using TIM framework, which stands for Torch Image Models. You can just do pip install TIM and you can get this framework get started. Also, just a quick note, for all this to work, you need to have Pytorch, Torch Vision installed on your system, along with a CUDA a CUDA compatible GPU, and of course CUDA framework. So so in this example, I'm using an efficient net model, which is the sort of model image classification model which I'm going to be using. So so if you see, it has two functions, and underscore underscore init, which is the constructor, and a forward function, which will be called when you do the forward pass, or you pass the images through the model to get the predictions, right? So this init function will be used to so it will so first of all, the class will inherit the nn dot module. Then the constructor will have a few arguments. So model name, if it's going to be pre-trained, like that is it going to use weights or not, external weights or not, and the number of classes. So if you look at this line, which is of the most importance, I'm using the TIM model to take the name of the model, and I'm just creating that model and specifying if it's going to be pre-trained or not. Then I'm going to be replacing the last line of the last layer of that model, which is the classification layer, the head, with a linear layer with the input features as the same, but except the new number of classes are going to be different. In this case, it's one, because I'm only working on two categories. The forward function will basically pass the any specified images through the model, through the backbone, and it will return those predictions. Second is the data loader. So in the data loader, if you can see, so it has three functions. It has an underscore underscore init function, a get item function, and a length function. So if you want, so there are of course other ways of doing this too. I make a custom data loader for every single thing, and I think it's one of the things that I've also noticed a lot in Kaggle. It's a much more customized and flexible way of doing things. So as always, the init function is basically for initializing your variables and everything like that. The get item function is to get the item, or get, so when you use the data loader inside a loop, this get item function, in this example, let's say I'm using OpenCV to read an image, and this operation will essentially, so this colon colon and reverse operation will basically convert the BGR image to RGB, because OpenCV by default reads an image in BGR, blue green red format. We need to convert it to red green blue format, so this operation does that. I'm checking if we need if there are augmentations or transformations. So if there are, then we are going to apply them, and at the end I'm just going to see if it's a training image or not. So, and if it's a training image, I'm going to also return the corresponding label. Otherwise, I'm just going to return the image. The last function is the length function. So this will basically return the length of the data set. So nothing more than that. So you need, in order to make a data set, you need all three of these functions overloaded. Yeah, so now let's get to the training function. This is a very basic training function, by the way. It's not a complete training function, like it can be optimized further, which I'm going to cover in the later parts, but it's a basic training function. So I have made it a function. So this is something called running loss, which I'll get back to in a bit. So this loop will basically get the batches of image and their corresponding labels in the loop. So I'm going to get, so x train. So let's say for the first iteration, the x train will consist of, let's say you have specified 32 as a batch size. So x train will have 32 images, training images, stacked on top of each other, and y train will have the corresponding 32 labels, like 0 or 1, say, stacked on top of each other. So I'm going to take one batch. So for first iteration, this is one batch. I'm going to take one batch and I'm going to transfer it to the device, which is in most cases CUDA, and I'm going to convert it to torch.float data type. So float data type. Same thing with the Y train. Then I'm going to get the output by passing on through the image to the model, and then I'm going to calculate the loss by passing the outputs and the ground truth value, which is Y train, to the loss function. Then after I've calculated the loss, I'm going to do backward propagation. So I have to calculate the gradients to do optimization. So I will do loss.backward, which will calculate the gradients, and then I'm going to do optimizer step. So what this thing does is that it takes these gradients calculated by loss, and then it applies them using the sort of optimizer you are using. So if you're using stochastic gradient descent, SGD, it will use these gradients and apply them through the SGD equation, so which is the partial derivative of loss with respect to all the other variables. Then I'm going to clear out the gradients. Since gradients have been already applied to the optimizer, I don't need them anymore. So I'm going to clear them out to make way for the next batch, which I'm going to be doing in the next iteration. And finally, I'm going to add the current loss to the running loss. So after all these iterations, let's say I have 100 batches. After completing 100 batches, I will have an accumulated loss of all the 100 batches inside this running loss variable. So when I want to print it or return it, I'm just going to divide it by 100 if I have 100 batches, let's say. So it will give me the average loss over all the batches. In other words, it's also called the loss of the epoch. Right, so this is the validation function. So the training one is done. So the validation function is even simpler than the training one. So in training one, you're calculating loss, and after that you're doing this optimization and training steps. In validation one, the running loss concept remains same. However, we do not so we use torch.nograd and just a second. Yep. So we use torch.nograd. So what this torch.nograd does is that it basically makes sure that whatever happens inside this scope, so inside this block, doesn't have its gradients calculated. So you don't have the gradients calculated inside this. So I'm as just the same step, I'm getting the X and the Y, so the corresponding X and the Y batches. So this is like one batch, transferring them to the device, getting the outputs, calculating the loss, and just getting the loss so that we can, after that, we can print the loss and see how well our model is performing on the data it has not seen. So this completes the basic image classification example. This is the bare minimum that you need for this example to run. If you, by the way, visit the notebook that I've given the link, it will be a bit more sophisticated and complicated, the training and validation functions. I'll cover that a bit later. So yeah, so let's get to the part where we discuss best practices for writing PyTorch code, right? So there is one thing that I want to mention is that this thing of best practices is a very subjective topic. That is, some practices may or may not be agreed by everyone that it's a best practice, but I'm just listing the practices that I found the most helpful and that have helped me write better code and make better notebooks. So the following are the ones that I found helpful, right? So the first thing is training code without functions. So this is one thing that I really did a lot when I was first starting out on Kaggle making notebooks, and I saw a lot of other people doing this a lot. However, I don't do this anymore, and I will tell you how. So inside the main, so there are two ways of writing your training code. So you can either write your training code inside different modular functions. So one for training, one for validation, as you saw here. So this is one for training, one for validation. Or the other way is just writing this all at once or in one single place. So as you can see, so this, if you notice very carefully, this is the epoch logic. So this will iterate you over multiple epochs, and this one is the training. So if you look at this, it will resemble quite closely of what I discussed some time ago. So this is one of the approaches in that which you just write everything all at once without dividing it really. So that's one of the approaches. Now it has some benefits but uh, a lot of problems. So first of all, it's less lines of code. You don't have to demarcate different functions and divide them, and it takes less time and effort initially. That is, in the longer run it is hard to maintain, so as you can see, and it's hard to debug. So for example, if you face some error, so let's say you put everything inside one huge file, it's very hard to debug. It makes the code a lot dirtier, right? So it's not very manageable in the long term. Now the other approach is using functions. So this is the one that I have used, or that I use more more closely. So in this one, you just divide multiple functions. So for example, you want to do training for one epoch, so you just add this in a different function. So as you can see, I have separated this thing in a different file called functions.py, and I will just import that function, so train one epoch, in my main file. So this is the main file, train.py. And if you see this main logic, so this one, if name equals main, in this one it had all the code in one place, but in this one it's a lot cleaner. So it has the epoch code, but at the end it's just train one epoch. So I'm just calling this function. So in the main file, it's a lot easier to debug, and it's a lot easier to maintain in the longer run. So the only side effect is that it takes more effort to write it in, like, to write the code and maintain it in the shorter run, but in the longer run it will actually help you maintain the code quality. Now, for the other part, I'm going to discuss a bit of object-oriented programming. So for those who don't really know object-oriented programming, it's a programming paradigm, or it's like a way of programming in which you rely on classes and objects. So you basically, so the main thing that you do is that you structure your code into um, small reusable components, right? Blueprints. So these are called classes. So using many classes, you can create their individual instances. So this really makes your code more reproducible and easy to and more modular, which is the right word. So yeah, and I love classes. This is why I use them everywhere. Like anywhere that I can use them, I try to make my code more object oriented. So so the first thing is classes to the rescue. So this is the sort of approach that I'm using currently in my Pytorch code. So I wanted initially, so I had this train one epoch function, validation one epoch function inside a file. I thought maybe it's a good idea to have both of them inside a trainer class. So what this will do is that the code will be inside the trainer class, and so it will have a constructor which will have all these. So if you take a look at it, I'm doing nothing but just taking the arguments and assigning them to a private member, like making them a member of this class. And so yeah, so and then in the next one, if you see, it's just the same train one epoch function, except it's train one cycle. So what this one does is that it takes only one argument, which is self. So since it's a member of this class, it only takes self. Everything else is an internal member, so we don't have to worry about that, so we can just access them. So if you take a look at it, I can just set the model to model, like the training mode, and then I can do the model training by itself. So if you see this self.device and self.train, these are basically, so self.train is the training data loader that I got here, and self.device is the device that we're doing. So this makes the code more approachable and more object oriented. And at the same time, you can just call this function anytime by calling this function on an instance of trainer class. So for example, you make an instance, let t is equals to trainer, and then you can do t dot train one cycle, and this will work all fine. The same logic with validation one, so you can do this with validation one too. So this is what I've done, and if you take a look at the cassava leaf disease notebook, this is the exact approach that I'm using there. So similarly, you can just make a instance of trainer class and call this function. Now, the other thing is augmentation in classes. So not just training and validation function, I also use augmentations, and I really like to put them in classes and then divide them in a different file. So I haven't listed it here, but so in my script based approach, the way I've uploaded my scripts on GitHub is that augmentations have a different file, so augments.py. So that's a different file, and if you take a look at it, it's not probably the best way of doing these augmentations, but it's a rough way, it's a quick and rough way to divide them and make them a different class. So these are training augmentation and validation augmentation. You can also add inference augmentation and put them in a different file. Now the other thing that I do is for optimizing code. So these were all about classes. Now let's get to the other point. So the other thing that I do is and I've seen a lot of big Kagglers do it, and this is where I initially got the inspiration to do this as well. And this has proved to be a good practice in the longer run. So the other thing that I do is use config classes and dictionaries. So let's say you want to have a learning rate, like you have a learning rate, and you have number of epochs and number of splits and train batch size, validation batch size, etc. Now, one approach is that you can have them all specified in one cell or one specific part with capital letters, and then you can use them. But then it creates problem if you want to, let's say, have multiple ones for multiple models. It can create problems. So in that case, what you would do is, what I have seen work better is that you make a different class or you can also make a dictionary. It's totally up to you. And you put everything like hyperparameters or something that you want to tune using like a few changes, like a few line of changes. You can just put them inside one different class or one different dictionary. So this way, and if you the another optional step is that if you just put this in a completely different file, you don't have to always change your main training file. If you want to say try out two different models, let's say you want to try out efficient at b4 and resnet 150 for example, you don't have to go to your main training code and go at every different place and change wherever the model is called. All you have to do is go to this one file and change this one line of code to whatever model you want, and have it binded this way that it will automatically get the changes done. Now the other thing is script based development. So this is something that I have found very so this was a concept that I couldn't really grasp when I was starting. So at first I really only worked in Jupyter notebooks. Like I did not do anything other than Jupyter notebooks. So I wrote my entire code in Jupyter notebooks, like the entire training, validation, and then submission code, like pre-process the entire pipeline, and then I just uploaded it as it is on GitHub. And from like a student's perspective, or from a perspective where you are searching for, let's say, jobs or something like that, it really is not a good thing, because if you have noticed, GitHub doesn't really load Jupyter notebooks very well. And the other thing is that Jupyter notebooks are really hard to read. Like if everything is inside one notebook, it's hard to read, even if it's divided in different classes. So what I've done, so this is the sort of structure that I follow, is that train.py is the main calling file. So this is where all the code is executed. Like you load the data, you pass them through the data loaders and everything, pre-processing pipeline, and you execute the code. And in the source folder, you have augmentations, a file for augmentations. This one is bytemp logistic loss, config folder, data loader, models, and trainer file, as I specified before. So this a good folder structure like that, or any good folder structure, actually it will help you organize your code, and it will make your entire process a lot easier. So now let's get to the optimizing PyTorch code part. Okay, so this is a part that I wanted to focus more on, because so you can write good code and you can organize your code and everything like that, but optimizing your PyTorch code, like the existing PyTorch code, to run like fast and efficiently and like use less memory at the same time, is an important thing, because believe it or not, GPUs and other space and compute power is scarce. Like it's rare and it's valuable, and so you want to squeeze each and every single gigabyte of space that you have, like the VRAM that you have. So following are some of the tips that I have followed, and that have really helped me to avoid these out of memory errors and the longer training times. And they have actually saved a lot of time, and potentially it can save you a lot of money if you follow them well and like use them at the right time. So the first one is using automatic mix precision. I think most of the people already know about this, but if you don't know, by default, a neural network is trained in a single precision format. So which is based on IEEE single precision. You can read it some computer architecture stuff. So with mixed precision, so this is like NVIDIA's technology. So with mixed precision on uh, automatic mixed precision enabled GPUs, which I think most of the GPUs on Google Colab and Kaggle notebooks are enabled with that. So with that, you can actually train half precision while also maintain, like you can, if you want to think about it in a simpler sense, just think you can train your model while maintaining the accuracy and consuming less memory, like making the training faster. So this is what automatic mixed precision is, and it's available in PyTorch. You don't actually have to do a lot of things. So this is what mixed precision really is. So it's fairly easy in PyTorch. If you have an enabled GPU and you have that version of PyTorch installed, you can just do from torch.cuda.amp. So AMP is automatic mixed precision, and you can import grad scaler and autocast. So you can just make an instance of grad scaler, and uh, whatever model calculation that you have to do, like the forward pass, you should do it inside this you should do it inside this scope. So with autocast and inside the scope, you should do this entire thing and then calculate the loss here as well. And out of the scope, you can use this scale instance that you created earlier, and you can scale the loss. So it's same as you doing loss dot backward, except you are calling it inside another function, and the same as optimizer, except you're calling your optimizer inside scalar dot step, and then you have to do scalar dot update. So with these minimal changes to your existing Pytorch code, you can speed up your training pipelines. And this is a personal thing that I've seen. So I've personally seen about 8 times speed up when using AMP versus not using AMP. And this actually happened in the same cassava leaf disease competition that I was talking about. So my initial training pipeline used about its speed was 1 items per second. After using AMP, it was close to 7.9 items per second, which is nearly 8 items per second. So this is a huge change that I have noticed when using automatic mix precision, and I think it's really helpful in making your code run faster. So the other topic is speeding up the process of feeding data. So when you're when you're doing when you're feeding the data to your PyTorch model, there are two vague or two broad steps in which this whole process is divided. So one of the step is by you can just read the data directly and convert it into a torch tensor. So let's say you want to do some work on tabular data. So you read the data from the CSV file, for example, you read it into NumPy, and then you convert it into a torch tensor, and then you just pass it, and then you split it, for example, and then you pass it to the model. Now, the other method is using a data loader. This is like a more complex, more sophisticated, but at the same time more customizable method, which you can control a lot of things. And using a data loader gives you one good advantage, that you don't have to manually divide the data in batches. That is, it will automatically do this step for you, which is dividing the data into separate batches and doing this. So let's get over the first method. So this is using torch tensors. So if you look at this example, I already have an x and y. Let's say these are so x. Let's say these are 5 different numeric columns, and y is the corresponding uh, dependent variable. X, these are independent. These are dependent variables. So you have some x, you want to predict the y. Same thing. You are dividing the data on 20%. So the testing data set has 20% of the entire data set. The other one is 80%, and you get some x train, x test, y train, y test, right? So these are basic NumPy arrays. Now inside this loop, so you can do this before too. I generally have done this inside. So inside this, you can do X train. You can convert this manually to a torch tensor, specifies data type. Same thing with test, and same thing with the labels, which is Y train and Y test. And then you can pass these to the model. And by the way, if you don't know what this dot view -1 means, it basically flattens the output. So you can do accuracy and ROC AUC calculations easily. So this approach has some benefits but a lot of side effects. So it is easy to convert. So like you can quickly just get those values, and you can quickly just feed them into the model without thinking much, like converting them to tensors and feeding them. And it's also easy to debug. So if you, let's say X train has some Unicode error, for example, it will just give you the pointer that this specific variable has a Unicode error. So you know that there is a problem in X train, so you can solve it, right? But the side effects are actually a lot more. So it's slow, right? So it is a slow process. It fills up your memory, which is the bigger problem. So this can fill up your memory pretty fast, and you have not a lot of things to do about it. Like if you load the entire data in your memory at once, it's not the best way to do this thing, because recently so generally in deep learning there are data sets that are bigger than how much your memory can house, and so loading data in batches is the best way. So this way it's hard to make batches too. Now the other method is using a data loader. So this is the more complex one, the more sophisticated one, but at the same time it's more preferred one. So you can make your own custom data set. So you can just inherit this built-in torch data, so torch.utils.data.dataset module, and you can inherit them inside your own class. And if you paid attention earlier, I talked about three different functions. So the constructor, the getItem function, and the length function. So this is the constructor function where you have to initialize stuff and do the super self stuff. The getItem function will be used to essentially read the data and return a batch of data on an index that is specified to it, and the length function will basically return the length of the entire data set. And now you can take this data set, you can like make it a data set. So let's say you make, so this is so you make an instance of this custom data set, you pass it inside this data loader module given by Torch, and if you notice, you can have an option of batch size and shuffling. So this is the thing that Pytorch will do it for you. So it will basically shuffle your data, and it will also divide it into the batch size of the given size, right? And so when doing this here, it's a bit more lines of code. So you have to also, you can do this here too, you don't have to necessarily transfer them to device here, you can do this in the data set too, but you can just transfer them and take the predictions. So this is good because you can make batches easily. In this one, you actually had to do, in this torch tensor one, the main problem was that you had to do some matrix multiplication stuff, matrix indexing stuff to make the batches. Here in the next one, you don't have to do this. PyTorch will do it for you. It's more customizable. So these are the three bare functions that you always need to specify. You can always add more, for example, and then you can have shuffle and other options. So this is just one function call or one argument specification away. And it's also memory efficient. So here you are just passing, so in this one, you're not loading the entire data into your memory at the same time, you're passing batches of data after one by one. But the side effect is that it's hard to debug. So if you use this, especially with asynchronous process, which I'll cover in a bit, it makes, so if you have an error at some point, which is like a very basic error, it will give a very nasty error, and it will be a bit harder to debug. But it's a trade-off, right? So it's really worth it to use this thing. And it also requires writing some boilerplate code, so you have to actually write boilerplate code, although you can use like a framework called PyTorch Lightning, which is much better, which actually saves you from doing the exact thing, so you don't have to write boilerplate code much, right? So the next thing is asynchronous data loading. So suppose you followed this approach, you made your own data set, and you want to make sure, you want to speed up your pipeline. So there is always an option which is asynchronously loading, like data loading and augmentations. So if you, so by default, this data loader has takes this argument, which is num workers, and by default it's 0. So it's doing this synchronously or sequentially. You can also specify this to any number between 0 to 8. So for example, this is 4, this is the number that I use most often, so number work is 4. It really depends on your CPU and GPU. So this will fast the process by doing parallel processing. It will, this work will be done in parallel on separate workers sub process. So this is where using data loaders is really a huge thing. This is where it really comes into play. Now, the other thing is using pinned memory to fasten the data loading pipeline. So this is something that not a lot of people have known in the past, and I myself have known this very recently. So there is this also this argument called pin memory equal true. So it by default is at false, but inside the data loader you can actually specify it to true. I have personally used it on training set only, never on the validation set. I'm not sure the reason, but it's just the way it has done. So if you're using a GPU, if and you turn this to true, it will enable you faster an asynchronous memory copy from your RAM to your GPU. So what happens is that your RAM and GPU are two separate units, and when you load, so when you use a data custom dataset data loader, it first loads the data in your RAM, and then it transfers it to your CUDA GPU. If you turn this option to true, it's actually going to make it faster, because the memory is, so let's say you have a batch which is, let's say 786 megabytes. 786 megabytes of memory transferring from VRAM to your GPU's internal storage is a process which takes time, right? Because those are two separate physical locations in your hardware unit. So if you specify this to be true, it will use something called paged memory, and this will enable you faster and asynchronous memory copying. Okay, so using disabling gradient calculation for inference. So when you are training a model and you want the gradients to be calculated, right? But at the inference time, so let's say you are doing validation, or let's say you're just getting the predictions for your model when it's at production, for example, you don't really need the gradients because it can cause you a lot of problems. Most important of all is that if you accidentally apply the gradients when doing the on the validation data, so the gradients calculated on validation data, if you apply them to your model, it can cause your model to overfit because it will then learn accidentally enough, but it will then learn on your validation data. So you can't really trust the CV that you get, and it can also cause you out of memory errors. This is something that I've caused a lot, and like this is a major hair plucking reason of mine that I have faced in the past. So I was getting the predictions for the submission file, and I was just passing all the predictions at all the testing the features at once, and I was getting an out of memory error, and I was very confused as to why it's happening. Turned out that I had the gradient calculation enabled, so I didn't disable it, and hence it was giving me this error. So there are two methods of doing this. First is using with torch.nograd, which I covered before. So this is a method when you don't have a function. You can also use this inside of a function, but I generally use it only when I don't have a function. So let's say my code is like 5, 6, 7 lines. So it's like too small to be in a function. So I do this with statement, and inside this block, inside the scope, I do all the things, and then all these operations gradients will not be calculated. So this is especially helpful if you don't have a function, let's say, so you can just use it directly and you can use it in continuation with your normal code. The other one is using torch.nograd. So torch.nograd, so if you take a look at this is a decorator in Python. So let's say you have a function, an inference function. You can just decorate it with this one. So this is the same function call, if you notice, torch.nograd parenthesis torch.nograd parenthesis, except it's like an @ sign, which is a decorator in Python. So in this case, you don't have to do that with statement inside the block. You can just decorate any function you want with this decorator, and its gradients will not be calculated. So this is like a much cleaner and more let's say Pythonic way of doing this. Suppose you have multiple, like your code divided in functions, you can just decorate all the functions. You don't have to go to each and every code and like indent it one tab and add a statement. You can just decorate it on top and have its changes get into effect. See, so another of the optimization technique that I've recently noticed is the set to none argument in the optimizers. So after you train your model, and wait, after you train your model, you do the optimize loss dot backwards. So you calculate the gradients, you do optimizer dot step, you clear the gradients using optimizer dot zero grad, right? In some select cases, that is, you have to pay very strong caution. In some select cases, you can pass in this set to none equal true. So what this will do is that, so for that you need to understand what zero grad does. So what zero grad does is that it goes to the entire computation graph and it sees which variables have the gradient calculation enabled, and then it goes to each and every one of them and just disable and just takes their gradient value. So it's something called grad, and it disables the grad to zero. It makes the grad to zero. So all the gradients are made zero if you do this optimizer to zero grad. When you do set to none equals true, it won't actually make them zero, it will make them none. So if you have studied Python for some time, you will know that zero and none are two very different things in Python. They don't mean the same thing. So this, as in noted in Pytorch recipe for memory optimization, this actually reduces the number of memory operations and it slightly increases the performance. But you need to take care, like you need to pay very close attention to this, because in some cases it can cause performance issues, since the numerical behavior of none and zero are two very different things. So you have to take special care of if it's not working. So let's say you try this on 5 batches. If it's not working, you should refrain from using it because it can cause you a lot of troubles down the line. The other thing is using is fusing pointwise operations using torch.jit.script. So let's say you have a custom loss function. Let's say there is a loss function that's not currently available in Pytorch, and you implemented that loss function, right? Or let's say you have a custom activation function, you implemented that activation function. You can decorate it with using add torch.jit.script. So what this will do is that it will make the process faster, and it will also compile it for Pytorch so you can calculate gradients. The main idea inside this is that after using this decorator inside a function, you should fuse pointwise operations. So let's say you have a dot product and an addition and a subtraction. So a cleaner way of doing this would be you make a separate variable of a dot b, and then you have one which is like c dot c plus d, and then d minus e. So you can have three different variables, or you can perform these operations one by one, like not at the same time, which makes the code a bit cleaner. But if you do all these operations in just one single line, so which is fusing the pointwise operations, it will be less memory expensive, because see, the pointwise operations are memory bound. So on a quick a quick way of understanding this is that for each and every operation, Pytorch will launch a separate kernel, right? And it will load data from memory, perform computation, store the results back. So this entire thing, this entire process takes time. If you do this separately, it will take, so if three operations can be fused, it will take 3x the same time. If you fuse them, it will take just 1x the time. So it will save you a lot of time if you're using custom functions. And this is very useful if you're using if you're making activation functions, optimizers and custom RNN cells. The another point is avoiding unnecessary CPU GPU synchronization. So when you do, so let's say you have a CUDA tensor which is inside your GPU, you do CUDA tensor.item. So this will basically load your tensor from your GPU, it will transfer it to the CPU, and it will print it to you, right? This causes your CPU and GPU to get synchronized, and CPU should always ideally run ahead of your GPU, which is your accelerator, so that there are many process in your work queue inside your GPU. So you should avoid these operations as much as possible. So quick example is, if you take a look at this, I'm calculating the loss, and then I'm doing loss.item for printing the loss, and then I'm adding the loss inside the running loss. So this is a very small example, but it shows the point. So I'm doing loss.item 2 times, which is a potentially memory expensive operation. Let's say you do this 3 times or 4 times, or even maybe more than that. It can slow down your process. So a better way would be to do, so you just do loss.item once, you save the results in a variable, and you use that variable 2 times. So this process is not taking as much time as this one, because you are essentially doing this only once, and here you're doing this 2 times. So the last one is deleting variables and freeing up space. So when you're training bigger models, and this is something that I face a lot often. So suppose you're doing k folds training, you have 5 folds, training your model for 5 folds. After every fold, so let's say you have 5 epochs in every fold, right? After first fold, you have to do 5 more epochs again. So when this happens, you have a lot of intermediate variables that are persisted into the memory, and when the next fold starts, or the next epoch starts, they will be added on with more variables. This will eventually cause your entire setup to run out of memory. So a good idea, a good way to solve this is just using delete keyword in Python, and space, and all the variables that you want to delete that can be deleted, following by gc.collect, so garbage collection.collect, and you can do this by import gc. This is an inbuilt module in Python, and at the end you can just call torch.cuda.empty cache. So this will essentially empty all the cache that is stored inside your inside your CUDA, inside your graphics memory, or the memory that's allocated for your operations. So yeah, are there any questions?
Yeah, hello Tanay. Thank you so much for this informative session. So our viewers have some questions. Let's quickly jump into the Q&A session. So the first question is very generic question. We usually ask this question to everyone. Like, what was your way to learn machine learning, and when did you get started?
Okay, so I really started after class 12th. So this was like the break between your 12th standard and your college. So it was this 3 months break. So I started learning machine learning really then. And the way by which I learned machine learning is that since it was after class 12th, I already had a lot of maths knowledge with me. So I did not really need to revise that much. But if you do, you can use Khan Academy. These are really great lectures because maths is a very important topic for machine learning. For learning the core ML, I started with Andrew Ng's course on machine learning. Some people say it's in MATLAB, so it's a problem, but MATLAB is very close to NumPy and Pandas. Even if you don't understand that, you should just continue with the MATLAB one. It's easy to understand MATLAB, like they will also teach you. So I think clearing the basic concepts of machine learning first and then going to deep learning is a better idea because it really serves as a good foundation. Deep learning is a more attractive one, so many beginners just jump onto deep learning quickly, which is, I think, one of the common mistakes that even I did when I was in my first year. So you should totally avoid that.
Yeah, so it totally makes sense. Foundation focused approaches always work. Okay, so the next question is our viewer asked that I have seen some people not doing this valid underscore loss dot item divided by length of data loader and rather just print loss dot item. So, do you have any comments on it?
Yeah, so I think what they might be referring to is they're just printing the loss as it is. They are not printing the average loss, they're just printing the current intermediate loss. I think that's at least how I think of it.
Yeah, makes sense. The next frequently asked question is like how the question is from Anmol Bhatia. Like he's new to PyTorch and have just started learning deep learning. Can you suggest some ways to learn PyTorch?
Yeah, so I think PyTorch docs are really well informative. Like most of the people don't go to docs first, they just watch some videos or stuff like that. But PyTorch docs are really informative. If you for some reason cannot read, like if you don't want to learn from docs, there is this YouTube channel by Sentex, so Sentdex, and he has a good PyTorch playlist. This is where I started PyTorch. And other than that, there are really great notebooks on practical PyTorch code in on Kaggle. So you can just go to any image classification or audio classification competition and just look at PyTorch notebooks, and they are really good to get you started.
Yeah, sure. I hope this will help our viewers. The next question is why people don't use argument parser.
Okay, so if you are referring to notebook based approach, like if you are referring to, let's say, Kaggle, for example, argument parser can't really work. There are many reasons for this. So first is you can't pass in arguments. Like you can do this easily without passing arguments. If you're referring to script, I think argument parser is for people a bit difficult to understand, or maybe it's really a thing about personal preference. I've used it sometimes and I still use in some of my projects, in other ones I don't. So I think it's more of a personal preference problem, but in Jupyter notebooks I don't think it really makes a lot of sense to use argument parser because you can just do it without using it.
Yeah, sure. It depends totally on the interface. Okay, coming. Let's go back. Go to the next question. So, when it is better to create a class versus creating a function?
Okay, so that's actually a good question, and I've wondered this myself too for a long time. And I think if your code if so I created a class specifically because I wanted my training and validation function, and there are actually more functions in my class. Those are the only few ones that I've shown, so there are more functions. So I created a class when I thought that it would be better to have these interconnected. If you have, let's say, very small training functions, you can just put them in functions, like very small training code and validation code, you can just put them in functions, put them in a separate file, and it would be a better idea. But let's say you have a huge training function and validation function, and they're interconnected in some ways, like you want multiple functions with your training functions. I think then using a class would be a better idea.
Okay. The next question is why don't you use pin memory as true for validation?
Okay, so this is something that I've been a bit scared about. I have used this once in a competition, and I'm not sure if it was this reason, and I'm by all means a beginner, so I'm quite possibly wrong. But I used pin memory equal true for validation, and it actually gave me a lot of errors, and it was related to torch out of memory and stuff like that, and bad memory sector access errors. And I looked at other Pytorch notebooks by big people, Kaggle grandmasters, and I noticed none of them or very few of them actually used pin memory equal true for their validation in that specific competition. So after that, I have maintained this practice ever since. Plus, my validation set is like fairly small, so it doesn't make a lot of difference if you use pin memory or not, because it won't take a lot of time transferring this small amount of data from your host to GPU.
Yeah, sure. Makes sense. Okay, so the next question is it is from Trupti. Like, what I should write in three parts of data loader and what not?
Okay, so the init part, which is the constructor, it's very customizable. You can write any sort of code. So suppose you want to append a path in a CSV file, you can do this in the init part. I do this in the init path all the time. If you take a look at the slides, I've done this in the first few slides. In the get item function, you have to make sure you have to write the code which, so let's say you're talking about an image classification, you have to write the code which loads the image for the given index, and it does the augmentations, it loads the corresponding label, and it returns it. And the length one is just for returning the length. So let's say you have one CSV file inside your data loader, just return the length of that CSV file. Let's like pandas data frame, so length df, this is all that you have to do.
Sure, surely it will help our viewers. The next question is in which cases using AMP does not give you a boost in the training time?
Okay, so this is, I'm not sure if this is the right thing, but in a recent competition, which was a search for extraterrestrial life competition on Kaggle, which is going to end in a few days, I used AMP, and this was, by the way, the first I started using AMP recently only. So this was one of the competitions where I used AMP, and it actually decreased my speed, although by only like 1 or 2 items per second, but it really decreased my speed. So it's more of a trial and error thing, and many people in the comments actually suggested me that it might be some bug in Pytorch because someone else was also going through the same thing. But in most of the cases, I think AMP should perform better, but it really is a matter of trial and error. So you should do a lot of trial and error before deciding your permanent and your main training pipeline.
Surely it will help. The next question is how to find ROC in PyTorch.
Okay, so what I do, so there is this new framework called Torch Metrics. I haven't used it yet, but so you might want to visit that. Other than that, to finding ROC AUC value, I used scikit-learn's built-in ROC AUC function. So I take all the targets and the predictions, I convert them to normal CPU tensors, then to NumPy arrays, and then to lists, and then I pass them through the function. So that's the approach that a lot of people use. Although you might want to check out Torch Metrics, I think it's promisable.
Yeah, great. Okay, let's have the next question. Passing data frame into the image dataset class versus passing image paths and image labels, which one do you prefer? And is there any difference?
Okay, so if you pass a data frame, you're just in most of the cases you're just passing a single variable, like let's say data or df or whatever, and you can do all the dividing, like dividing the paths, the labels, appending the paths with the parent directory path inside the class, inside the data loader class. The other or in the image dataset one, the image paths and image label one is, in my opinion, which is, I think it's a very subjective thing, so it really depends, and it doesn't create a lot of difference in how good or bad your code looks. Like it's not a difference too big to think about, but to me, I personally prefer passing a data frame.
Sure. The next question is how to become a notebook master. Any tips?
Okay, so I think I only have like one word, which is consistency. So I think if you want to become a notebooks master, make sure you make good, valuable notebooks, right? You make the approach that I started at first. I made more EDA and visualization and basic data preprocessing, basic machine learning notebooks. But at some point I switched more to making training notebooks in competitions. That has really helped me. So this also has helped me personally learn more about deep learning and competitions, and also uh, get more attention to my notebooks. So I think consistency is the key, and a very important part is learning from other grandmasters and masters notebooks, and like high voted, top voted notebooks. They actually teach you a lot, and this is something that people look over, but you should learn from it, not copy them, but just learn from them. Take the inspiration, infuse your own methods, and make better notebooks.
Great. Let's have the next question. Can we know how do you got selected in NVIDIA internship? It would be so valuable for the viewers.
Okay, so I think this is like a very basic thing. You have to apply through the portal, and then there are multiple stages and processes. I think a very important thing is having good projects, and make sure you not only meet the requirements, but also have projects in the same area where you're applying, for example. So having good projects actually helps a lot. Having good technical knowledge helps a lot.
Sure. The next question is, can you clear out the difference between test and validation sets?
Okay, so so for me, and this is confusing to a lot of people, and it has been confusing to me too. So training is just the training set. Validation one is the split, is the small subset of data which you get from the actual main data set, right? So validation is when you validate your model on so you train the model, you want to validate on a small subset of data if it's how it's really working. And the testing one is is the data you want to predict. So the data where you don't have a y variable or the target, you just have the x variable and you want to predict y. So testing one is, if I'm talking in terms of Kaggle competition lingo, the testing one is the data, the submission file which you want to fill, and the validation and training ones are derived from the main training data. It's split from the main training data.
Sure, sure. Um, could you recommend your favorite Kaggle notebook with a complete pipeline in Pytorch?
Okay, so I don't have an exact like one specific Kaggle notebook, but if you really want, and the notebooks that learned a lot from is Y Nakama's notebook. He's a notebooks grandmaster, I think, and his notebooks are generally complete in terms of. Uh, so he kind of makes like two notebooks, one training and one validation. So you should really look at his notebooks. It's a good way to learn more. So yeah.
Surely it will help. The next question is, what kind of projects did you have?
Okay, so I think it's like a, a very vague question. So, but most of my projects, so there was one project that I made which was my own little deep learning library which I made from scratch. So let me just quickly go over it. So in frameworks like Pytorch, you calculate gradients using code. So in bigger frameworks, you use something called code transformation, which is a very advanced topic. I used data structures and algorithms and everything to make a little framework like Pytorch. This is, I think, one of my best projects and one that I'm really proud of. The other projects are mostly off Kaggle things, but in most amount they are the projects, the pipelines that I made for Kaggle competitions, and I divided them into script format and I put them on GitHub.
Surely, surely. The next question is, any tips for someone who is just getting started with Kaggle?
Yeah, so I think like the starting part is the most hardest part, or the part which will scream at you, give up. It's, you can do better things. But if you keep working, if you make genuine stuff, whatever the place you want to work in, competitions or notebooks, and if you have consistency, you should know how to learn from notebooks as well as discussions. This is an important part. And so yeah, learn from others works and communicate with people in the community. That's, I think, one of the best ways of doing it.
Yeah, thank you, Tanay, for such a brief and good answers. Thank you, Aman, for hosting the session so well.
Sure.
So thanks, Tanay. It's great. It's
Thank you
great
guys.
meeting you
Thank you
once
guys for
again.
having me.
Thank you.
Yeah.
I
Thank you,
shared a
guys.
stage with Tanay a few days back. Sure.
Yeah.
Thank you, Tanay, for your time. And do send the presentation to me on LinkedIn, right? And I will make
Yeah.
sure
I'll
to
send
send
you.
that presentation to others. Thanks, Aman,
Yeah.
for being such a great host, and thanks, Tanay, for
Yeah.
giving your time for the community. Thank you, guys.
Yeah.
Bye bye.
Thank you, guys. Bye bye.
Thanks, everyone. Thanks, everyone. Bye.